Hello everyone. In today's lesson we're going to be talking about the binomial theorem. So first, let us recall back, I think in Unit 4 when we were multiplying binomials and polynomials, we had something called Pascal's triangle. And so if you recall, when expanding binomials of the form a plus b raised to the n power, we see a special pattern arise from the coefficients of the variables. And this pattern is called Pascal's triangle. And so we had the 0th row, 1st row, 2nd row, 3rd row. That's just basically the power that we are taking our binomial. So for that first row, we have a plus b to the 0 power. That's just equal to 1. A plus b to the first power. That's just 1a plus 1b. A plus b to the second power. That is 1a squared plus 2ab plus b squared, and so on. And so we had this Pascal's triangle written as numbers of the coefficients of these variables. We have 1, 1, 1, 1, 2, 1, 1, 3, 3, and 1. So we have a 1 in front of both of those b's. And so we start with 1 and 1, 1. This 2 right here is the sum of 1 plus 1. 3 is the sum of 1 plus 2, and that pattern would keep going. And so I'd have 1, and then 4, 6, 4, 1, because 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and so on. And so we already talked about this, but that was the pattern that came. Well, we can also write Pascal's triangle as combinations. And so I could have this as 0c0, which is just equal to 1. 1c0, which again is equal to 1. 1c1, and so on. And that brings us to the binomial theorem. And that says for any positive integer n, the binomial expansion a plus b to the n power is equal to this long thing. So we start with our power, so n c0. So our power that we're raising our binomial goes there. And we start with 0 for our combination. A is raised to that power that we are taking, and b is raised to 0. And basically from there, we see for the c's, the n stays where it's at, but we're just going to add 1 each time until we get to n. For our a term, we're going to subtract 1 each time until we get to 0. And then for our b, we're going to add 1 each time until we get to n. And so something to note is that each term in the expansion of a plus b to the n power has the form ncr a n minus r b to the r, where r is an integer between 0 and n. So next video, we're going to be looking at applying this theorem to expand some binomials.